So it is about time for us to look at the calendar. Today is going to be our last regular lecture before your first exam, which is a week from today. So we're going to talk about overriding and overloading, actually, both of those today. Next time we will talk about the first program, which is due the 13th. Okay, we're going to spend that entire day discussing it. Now we've got all the concepts that are involved in, we will, after today, have covered all the concepts that are involved in Program 1. So there's still plenty for us to discuss. It will probably take the whole class. It might not, but it probably will. Then for the review on the second, what I do is I bring in an old exam, usually the one that I gave at this point last semester, and we work through it so you can get an idea of what kinds of questions that I ask. And there's going to be a lot of programming. So that'll probably be worthwhile for you to see how those questions are going to be structured. And then on the 4th is your exam. Okay? Now, fortunately, there's nobody in here before or after us, to the best of my knowledge. So if you are one of those people that would like a little bit of extra time, I will probably come in here, maybe 20 minutes before our class would normally start. And if you want to stay about 20 minutes after or something like that, that would be okay. Okay? I do intend on making the exam fairly short. So, what we cover in the review will probably be longer, or depending on how much of the exam we actually go through, it's possible that it will be about the same length or longer than the test I will actually give you. Okay? So this class is gigantic, especially grading these exams. It's quite a chore because there's a lot of partial credit. Okay? So I'm going to try to break down all the components of the programming question into their own separate little sections to make it easier for me to grade. All right, so then after the exam, we'll start the next topic, which is interfaces. All right, so for today's lecture, I want to pick up with where we left off last time. And that is, we had just gotten to the point where I gave you the rules, the simple set of rules for polymorphism. Definitely something you're going to need to know for the exam. So does anybody remember what the first rule is? It has something to do with the declared type. Correct. Determines what can be called. Now, obviously, when you have an exact match between the actual object created and its declared type, it's pretty straightforward that you can call anything that's defined in that class, and that's the method that's defined in that class is the one that will be called. Okay? But this is limiting in a lot of ways. So we allow now, what polymorphism allows us to do is have a mismatch between the type and the actual object. And that's where these rules come in. Okay? So there's nothing really that you need to remember if the type and if the actual object and its type match. Whatever's defined in that particular class, that's what you can call. Okay? But in the case where I change this to say employee, employee has a pay method. Okay? So I look at the declared type to give me the list of stuff that I can call. No matter what it actually is, the type tells me the things that I can call. The second part of that has to do with the actual object. What does that say? Actual object determines something. Determines, yes. Okay? So the type tells me the stuff I can call, but what's actually going to be called in this example, if I call h.pay, I'm not going to be calling employees pay method. I'm going to be calling hourlies. Okay? So that's the simplistic way of how polymorphism works. After we get done with the exam, we're going to do a lot more interesting stuff with polymorphism, as I've alluded to before. It turns out that inheritance is not the most useful thing in OOP. Okay? What comes after the exam, we're going to still be using polymorphism, and these rules will more or less still apply. But there's a lot more flexibility with the stuff that we're going to cover outside of inheritance than what we're doing right now. All right, so that's the simplistic set of rules. Let's cover the detailed set. So let me set this up. I've got everything, of course, extends object. So I have object comes with an equals method, and what's the other method that object has? To something. Okay. There's a bunch of others. So if you go and look at the documentation for object, there's a bunch of stuff. But the only thing that we ever really need to concern ourselves with in this class are those two things, the equals and toString. Okay? So here's the equals method in the object class. I'm using, this is UML, Unified Modeling Language. You really won't see me list methods in here too frequently. What I care about in this class is the name of the class itself and how it's related to other classes. So the title you place on the box and how it's connected to other UML boxes, that's what we're interested in. In this case, it is a relationship. So we've got inheritance. Okay? So I need to show the parameters for our example now, but generally speaking, I'm not going to make you write out entire method signatures using UML. But here's how you read it. It's a public method. It's called equals. It has a parameter called O of type object, and it returns a Boolean. Okay, so we could we could very easily, if we know those basic ideas in UML, convert that to a regular old Java method signature. Okay, it's not hard to go back and forth between the two. Okay, so that's the equals method that exists already in the object class. And all it does is it determines whether the object that's calling the equals method is an alias to the one that gets passed in as a parameter. Okay, for this example, we don't even care what it does, but that's all it does at the object level. Now, we extend object and we create an automobile class. And it also has a couple of equals methods. One of them does something called overloading, and the other one does something called overriding. Which one? Well, let's start with the one that we've talked about already. Which one? Well, that will tell us what the other one is. Which one does the overriding? Let me number them. 1, 2, or 3. 3 is overriding. Okay? You keep the exact same method signature, but you give it a new method body, which could in fact include calling the parent equals method. You haven't lost the ability to use the inherited stuff. You can still write new stuff, but still call the super equals method if you wanted to. There's no reason to in this case because the object equals method doesn't do anything terribly interesting. Okay? But if you wanted to, you could call the parent method as part of your overridden method. Or don't have an overridden method. Just inherit it as is if it does the job already. Okay, you don't have to override, you don't have to overload. So that one is overriding, but overloading is something we also need to discuss now. It keeps this method signature, the name is the same, but we change the parameters. Okay, so this particular equals method accepts an automobile as its parameter. Okay. But we also have one that accepts type object, which is the one that's responsible for overriding. So when you keep the same method name, but you change the parameter list, that's overloading. Okay? So now I'm going to create 3 objects. I create object O is new object, automobile A is new automobile, and object AO is new automobile, where this last one is using what we were just discussing with respect to polymorphism. I now have the ability to use a type that's different from the actual object, as long as the type that I use is at the same level in the inheritance hierarchy or higher. Okay? It can't be lower, because employees, so if we go back to our staff manager, employees don't have access to the stuff in hourly and executive. Okay? Hourly and executive have access to the stuff in employee, however. So the rule is you can have a mismatch between the type and the actual object as long as the type is something higher in the hierarchy. And that certainly applies for this particular situation. Okay. Now I'm going to have to flip back and forth between slides, or else I'm simply going to have too much stuff on that slide.
You overload something that basically destroys any compatibility with a for each loop, right?
With a for each loop,
Yes.
well, when we start, at some point we're going to build our own classes that conform to for each loops. Maybe we can discuss that then, but I don't quite know what you're talking about.
Like if you iterated through a list of type employee or staff member, if you overloaded the pay function, like putting different parameters in, you wouldn't be able to iterate through.
This may answer that question. Okay, so the question is, what are the rules when you've got a complicated system of overriding and overloading stuff? That's what we're addressing right now. And it's complicated, so this may answer your question. Okay, so I'm going to call a bunch of equals methods. I'm going to call A dot equals O. I'm going to call A dot equals A. And A dot equals AO. And I have to give you the rules that we're going to be looking at now. So these are the complicated rules. So if you thought the first rules were complicated, well, bad news. These are more complicated. The compiler is going to look at the declared type of the calling object to find the best matching method signature. Okay, that is a more complex version of Rule 1. You look at it's declared type. So our old declared type was used in step 1. The declared type is still used in step 1. But now we're looking for the best matching method signature, not something that I said you would have to do in our simple set of rules. Okay? And the second part is, at runtime, the actual object uses or executes the method with method signature from step 1. Okay, so let me read through those again. Compiler looks at the declared type of the calling object to find the best matching method signature, whatever that means. Okay? That's at compile time. That information is remembered. The decision that the compiler makes in step 1 affects what happens in step 2. So there's stuff placed in your .class files that correspond to some decisions being made. Okay? When the program is running, we don't really know what the actual object is going to be. All we were talking about is the declared type at that point. But the actual object is going to execute one of its methods, and it's going to be the method that we decided on in step 1. Okay? So how that works is, in several of the cases we're going to look at, it's pretty straightforward. But in one or two important spots, it gives what might otherwise be a surprising answer if you didn't know these rules. Okay? So let's step through the rules for these 3 choices, and let's figure out which of the 3 equals methods that is actually going to be called. So the declared type, well, A was given declared type automobile. So all 3 of these are using the same object. So all three of them are going to be using automobile to complete step one. Okay? So we're going to find the best matching method signature. And that's going to depend on the parameters that we pass to equals. We know we're going to be looking in the automobile class. We know we're going to be looking at one of the two equals methods and the types that the parameters have. In this first one, the type is object. So let's switch back and forth. Okay, we can look in the automobile class. That's where we are right now. Does method 2 or 3 match better that method call? Which one matches better? (50-50) chance. What type is O? It's type object, right? Right down here at the bottom, type object. Which one matches better, 2 or 3? 3 matches better. Okay? If I pass in A, which is type automobile, which one matches better?
2.
And if I pass in AO, which we created to be an automobile, which one matches better?
2.
Okay, I tricked you. Declared type of the calling object, and of course just the types of the parameters. Okay, so I intentionally worded that. If I'd said what is declared type, you would have said object, and then I would have led you to 3. Okay, which is the right answer. The parameters, you just look at their declared types. Okay, so in that case, the best fit is 3. Now, is that going to turn out to be the one that actually gets run? Well, in fact, it is. Okay, because the declared type of A is the same as the object that it actually is. Okay? So whatever we decide from 1 is going to be copied down into 2. There's no extra analysis that we have to do in order to come up with 3 is actually is going to be executed, 2 is going to be executed, 3 is going to be executed. Okay? But if you're not on top of your game, it's possible that you would have gotten those bottom 2 possibly wrong, especially the last one. If you don't realize that it doesn't, I didn't say anything about the actual parameters that are passed. The rule says the calling object's declared type and the calling object's actual object, depending on whether you're in step 1 or step 2. In fact, let's add it in there, calling object. Okay, the actual object determines the thing that's going to be run. Okay? The next 3, I think, will be the easiest. Let's step through the rules. Compiler looks at the declared type of the calling object. What's the declared type of O? What is O's declared type? What is O's declared type? Okay. Glad we all agree. Okay? Find the best matching. I don't have a choice. There's only one method there. I have to commit myself to this method. It's the only one there. Okay? And then that runtime, the calling object's actual object, which in our case is, again, we have a match between the type that we gave the declared and calling object, like we did over here. They still match. Okay? So we don't have any extra complications that we're going to have in the third set of things. But we've already decided it's going to be method signature 1, and the actual object is type object. So we're going to execute method 1. So once again, whatever we decided in the first part, trivially carried on to the second part until we get to this third set. Okay? Compiler looks at the declared type of the calling object. What's the declared type of AO? Don't make me circle it again. Object. So again, we are committed to this method signature. Okay? But AO actually is an automobile. Okay? So we look down here in automobile and we find the one that matches the decision that we made in step 1. What is that? What method is that? 2 or 3? 3. And so this may come as a surprise. Okay? You may think that when you look in the automobile class, the parameter that was passed is type automobile. So it makes sense to think that that should call method 2. But that's not the way it works. Whatever we decide from step 1 has to be enforced. That method signature can't change in step 2. So that makes this the most difficult one to understand of all 9 that we've done now. That's the one that's going to trip you up. Okay? So, hopefully you appreciate the simpler set of rules. I would really like to not, so other than asking this on the exam and having you explain how this works, which I put it on a lot of tests and it usually gets missed. Okay? So these complicated rules are there to manage anything that we might possibly throw at the compiler in terms of objects, the declared types, their actual objects, the parameters that we pass to methods. All these other things can change because we no longer require the declared type and the actual object to match. They can be different. So that creates a lot of complexity in figuring out exactly which method to call. So, let me suggest a way that we can avoid this problem so that we never have to, other than the first test. After the first test, we would like to only have to remember this set. Okay? What can be called, what will be called. Declare type, what can be called, actual object, what will be called. Okay? Still perhaps not trivial, but a whole heck of a lot easier than this one. So the issue is, we can boil it down to overriding is not the problem here. Overriding, we're forced to keep the exact same method signature. We can understand and get used to through practice how that works. Okay? Follow these steps. That's how you figure out what, if it's just overriding, these steps apply. The problem comes with overloading. Introducing this new method that we thought was going to be called in a certain circumstance and looked like had every reason of being the one that would be selected to be called, in fact does not get called. Okay? So we're going to put a caveat whenever we want to overload methods, we're going to impose an additional constraint. Okay, we're going to give 2 options. The first option is don't. And that is change the method name. So overloading uses the same method name but changes the parameter list. Okay? We don't quite have to go to that extreme, but that is one option to us. Just not overloading stuff really is not an overly excessive burden on what we need to do as programmers. Okay? But if we really want, that method name is just really, really good, we don't want to change it. We insist on overloading some stuff. There's still an option. Change the number of parameters. So we got into trouble here. What it boiled down to is the method signature that we wanted to override had the exact same parameter list as the one we wanted to overload, just the types changed. Okay? But if we had we wanted to overload a method and we throw an integer in there, well, now it's going to be obvious which one is called because I'm either calling the single parameter overridden method or a multiple parameter some other method. So we don't want to have to look at code and have to think through exactly which method is going to be called. That's the problem. That kills readability. Not understanding which method is going to be called is the real issue. So if we allow ourselves to maintain the same method signature, but clearly change the number of parameters, then that problem goes away. Okay? We'll know exactly which method is going to be called because we'll see there's two parameters. So it has to be calling the two parameter equals method. Okay? So it wasn't really overloading that was the problem. It was in this special contrived case, I had the exact same number of parameters and the only thing that changed is their types. Okay, so that's where we got into trouble and had to apply the complicated set of rules. So yeah, asking you about this or maybe even giving you a setup like this and having you figure out which method is going to be called is something I could certainly put on the test. Okay? But from this point on out, we're going to do one of these two things. Either find another really good name for that method that also gets rid of any ambiguities. Okay? Sometimes adding a new parameter is just not necessary. So in that case, you probably need to change the name of the method and then it's clear which method is being called. It's no longer overloading anything. But in some cases where it does make sense to change the number of the parameters, then you can let the method continue to be overloaded, and again, the ambiguity is going to go away because you changed the number of parameters. Okay? So those are our two choices. Now, questions about that? So just put like 20 of those on the test and we'll call it a day. No, that would be bad. I gotta have some easy questions like remembering to make your instance variables be private. No, hopefully you'll all get that right.
Just rip up our test if we don't.
Pardon?
You just rip up our test if we
I should, but I won't. I'll just bang my head against the desk about 100 times.
Wall of shame.
Yeah.
So you come in with a black eye.
No, every node is its own global variable. Dr. Brown would just like kick you out of his class. He's like, you failed the whole thing.
Okay. Let's go back and do a little bit more stuff with our staff member hierarchy. So this will be the last of the material that could appear on the test a week from today. So we had a volunteer, an employee. Okay, although I won't put them on there, you know there's two more down here. All right, what I want to do is come up with a way of defining. So I want to define how staff members should be sorted. So one of the important things that we're going to do after the first test is come up with much better ways of defining behavior on a bunch of objects. So we're spending some time talking, sorting is one of those behaviors that we need to define. So, but for now, since the exam is on inheritance, let's see if we can't take an idea along those lines and make it fit into our inheritance hierarchy. Okay? So, what I want to do, if I want to define how all staff members should be sorted, and I want to do it the most efficient way, where should I place such a method? Pardon?
An
Object? I probably don't want to define a way that all objects are going to be sorted. Because remember, tires extend object, pizzas extend object. So it's not real useful for me to try to force everyone into the same framework. I'm going to have to override that method almost everywhere. But so if I only want to define how staff members should be sorted, maybe I don't need to go all the way to object.
Should you do it in between that way?
I could to put another class in there and inherit from it. I think you guys are overthinking it. I didn't mean for that to be that difficult.
Our staff.
Yeah, let's put it in here. Okay? That way, everyone below us will inherit that behavior. So if we decide that we change our mind about how we should be sorting staff members, we come back here. Okay? Now, the drawback is we're limited to the stuff that's actually available in staff member. Okay? That means we don't have salaries or bonuses or hours worked or any of that other stuff. But hopefully there's something in staff member that we can make use of. In fact, what were the variables? Does anybody remember what the variables were in staff member? The private variables? Name. How about that? Let's suppose we decide to just get started that we want all of the staff members to be sorted by name. Now remember, staff member is an abstract class itself. So I can't use new with staff member. I'll get a compile error. Okay? So, does that mean that can I write a method in here that does some work? Or do I have to make the method be abstract?
You can actually make it directly work on the name.
I can make it work on the name in there. I don't have to make everything abstract inside an abstract class. In fact, it's entirely possible that nothing will be abstract in an abstract class. That was not our case last time. We made the pay method be abstract. Okay? It didn't seem like it made sense to have a pay method in staff member. But in the children class it did. Okay? But staff member does have some data stored in it. So there's nothing to stop us from writing methods that use the data that's there. Okay? And then my children can inherit it as is, or they can override that method if they have a more special way that they want to sort stuff. Okay. The method that we use to sort stuff is compare to. And there's its method signature. Okay? So you have a calling object, object1.compare to object2. Okay? And that will return an integer. That's either going to return less than 0, equal 0. I think we did this for strings, but now we're doing it for objects. Less than 0, equal 0, or greater than 0. Okay? For strings, I'm comparing ASCII code characters. Well, we're not specifying what's being compared here. When we do the name and staff member, of course, we'll be comparing strings. But in general, the reason why I put object in here is we don't know the actual types that are going to be passed in there. Okay? But however, no matter whatever complexity is involved in the compare to method, whatever hoops get jumped through to figure out the ordering, we can expect one of three outcomes. Either object 1 should be before object 2. I'll get a less than 0 answer. And again, I don't really care what that number is. I only care whether it's negative, equal to 0 or greater than 0. Okay? If I get back a 0, they're equal. Okay? And if I get back a greater than 0, object 1 comes after object 2. So we need to conform to that convention. When we write our compare to method for staff member, we've got to remember that the way that integer gets returned, we've got to conform to this scheme. Whatever we come up with, we're going to decide on the criteria that determines which object comes before the other, and we'll make sure to return the appropriate sign. All right, let's go to, I have not opened those yet. We want staff member. And so here, I actually have a compare to method. So I'm comparing two staff members, presumably one of them is going to be calling this method, and the other gets passed in as a parameter. I've got my variable down here called name, which I can access within this class. And we already discussed the fact that strings conform to that convention. Okay? They compare ASCII code values, and then the ordering is like this. Negative number means object 1 comes first, etc. Or string 1 in that case comes first. So there's not really any extra work for me to do. In this case, I don't really have to do much because string itself has a compare to method that follows that convention. So all I have to do in here is get the name out of the calling objects right here and get the name out of the passed in parameter, which we wrote a getName method, which returns name. And since strings already do all that stuff correctly, that's pretty much all I have to do. In fact, let's call this, just call it other. That's what I normally do. Or even better, how about that? So that we can say this dot name dot compare to that dot get name. Okay, this and that. Strings already do it, so there's really nothing else I need to do here. However, let's suppose that we want to fine-tune how this is done in the employee class, so that if we happen to have the case where we have two staff members that have the exact same name, maybe I want to have a secondary field that figures out how to sort them relative to one another. Okay? And just to pick something, maybe the salary. We want to have sorted by name, but for people who have the same last name, we want to be sorted by salary, either ascending or descending, whatever we want. So I can reuse this code. I don't have to in the employee class, I can still make use of this compare to method. Because remember, we have a way of calling even though we're overriding the method, we can call the overridden method from within our new method. So in other words, I'm going to copy and paste this down in employee. Okay, and I can't call this directly because name is private. Oh, by the way, one other thing I wanted to mention. Although you won't really ever see me do this, let me get rid of this now. I could have said that dot name. That will work. Okay, I don't like to do it because it looks like we're trying to circumvent the private stuff. We should always call public methods when available. But just to tell you that will work because private still allows objects of the same class to access each other's variables. Okay? We can't really get around that. That's built into the language. But we can just get into the habit of not using that feature and make it look like, at least as far as our code is concerned, that private means only the object that gets called can access those variables. That's actually not the case, but we try to do things that way anyway. Okay? Well, I would really like to... So we got some issues here with types that we probably need to discuss. But for now, I'm going to go ahead and change it to employees, because let's assume that we're comparing two employees now. Okay? So if I want to make use of my parent method, which is going to compare the names for me, I can't call it directly anymore, but I can store the result of that comparison in a variable. So I remember whether it was positive or negative. Okay. Okay? And then I can manually call, so I'm overriding that method, although it looks, I've changed the type, so things are a little bit trickier. Strictly overriding would require me to keep the method signature the same. So let's do this for now. Okay? Strict overriding does not allow me to change the method signature. If I try to change that to employee, in fact, I'm falling into that trap that we were just discussing in that other example. Okay? So I would probably either change the name, not use the same name, or change the number of parameters, which really doesn't make sense in this case. But nevertheless, I can still use the method that I'm overriding here. Okay? I haven't lost the ability to call that method. It still exists. So I can call it and store my result. And I only, in most cases, I just want to go ahead and return the result. And I'm done. Because in most cases, the two people I'm comparing, because I'm trying to sort all my staff members, have different names. You know, probably last names. Let's say that we're keeping track of just last names by themselves. Okay? So they've got different last names. I don't have to do any additional work. That gives me the correct order. However, what is the result that will tell me that I have the same last name? In fact, let's go into staff member and say, assume last name, assume name is just the last name. When am I going to have more work to do? Under what circumstance?
You have two people with the same last name,
What's name result going to be in that case?
equal to 0.
Yes. Okay? So they were same last name. Now I need to distinguish based on a different value. And now that I'm inside the employee class writing this overriding method, I have access to pay rate. Okay? So now I can manually test. There's nothing complicated about comparing two doubles. If pay rate is less than, so pay rate would correspond to the calling employee. The other pay rate would be that dot get, isn't it pay that just returns the pay rate? Let's check. Yeah, it returns pay rate. So I could refer to it directly, assuming that that thing actually is an employee, or I can simply call the pay method. Now, I'm going to have a problem here. Let's see how good you guys are. This would be good kind of stuff that I'd probably try to put on a test. Can I call that dot pay, or am I going to get, well, the fact that I'm asking the question is you're going to get a compile error. What is that compile error? Why am I going to get it? Actually, that's not true. Why will that work? Maybe even more complicated. Why will that actually work? Nope, that's the wrong one. Where's that slide? Can't find it. Here? Yes. The declared type determines what can be called. The declared type was what in that problem? Staff member. So we go and look in the staff member class, and we find, aha, there's a pay method. It's abstract, but the assumption is I'm not actually going to be passing in a staff member here because staff member itself is abstract. It's going to be a child class of staff member, and I will automatically call the correct pay method. Okay? So I was going to say that we need to do some casting here, but in fact, we've defined through an abstract method signature, the pay method was actually defined in staff member. That's the design that we came up with last time. So in fact, this will work without a cast, which is always nice. Okay? So if pay rate is less than that dot pay, what do I want to return? That means that the calling object should come before, so I'm assuming that I want my pay rates in ascending order. So the smaller pay rate for all the people with some same last name, the smaller pay rate should come before the larger pay rate. what does our convention say about what we should return? Now I gotta look for that slide, wherever the heck it is. There. It's here somewhere. Where is it? Do I want to return a less than 0, an equal 0, or greater than 0? I want to return less than 0. Okay? So we could try to be precise and return the difference between the pay rates. In fact, I should store that in a variable and use other rate there. What kind of issues am I going to have here? Yeah, I'm returning an integer, and that, of course, is going to be a double. Okay? So we have to worry about, when you start doing arithmetic, although there's no multiplications or anything like that here, when we start doing arithmetic and stuff like that with doubles and floats, we have to worry about tolerances and all that kind of stuff. How close to 0 do we have to be for us to treat it as 0, blah, 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 blah. Okay? So there was a lot of extra overhead if we try to use this system. We don't really have to, because we can conform to that convention in a much more simplistic way. All I have to do, all it says is I got to return a negative number. Whoops, not there. I got to return a negative number. It doesn't say any particular negative number. What's a good negative number?
-3.
Negative 3 sounds good. Let's return negative 3. Code. Okay? Else, if pay rate is greater than other rate, what do you want to return here? You got to return what kind of number? Return 17. Else, what's my last choice?
0.
Okay? So in reality, of course, I'm going to choose -1 and 1 rather than -3 and 17. But they would have worked. Okay? Any negative number is sufficient for us to give the required information back to the calling, whoever was trying to do this sort. Okay? So that's one way that we can compare, that we can add additional information that's available in the employee class to modify the way that we were sorting stuff with the less complete information that we had in the parent staff member class. Okay? So as we have more information, as we work our way down the hierarchy, it's possible that the complexity of our compare to method will start to grow. We got more stuff that we can compare based on. In fact, it may be that we change our mind and would really like to sort by pay rate first, and then only if the pay rates are the same, then sort by last name. So we would simply sort of change the order that we do these two things. So there's endless varieties of how we can make this work. We can do something different at the executive level. Maybe we would sort them based on the size of the bonus that they had. Okay? So whatever the requirements for our reporting purposes for our staff member payroll is how we would define these compare to methods and get different lists of sorting stuff, after we've figured out how we want to do the sort. So when we write our sorting routines, we are going to be using compare to methods. Okay, at least at first. There is another version, since we're getting real on time, let me just mention the other. This is what, after the exam, we're going to start doing lots and lots more stuff with compare to. Okay? But there's another little bit better way that we can do those comparisons. If we use a different convention. The compare method accepts two objects. And let me try to explain why this is better. Okay? The compare method does not require that I have a calling object that has the compare to method. Okay? So the differences between these two things is this is assuming, based on my example here, that object 1 has a compare to method. I'm calling a compare to method on object 1. Okay? So that restricts me to, now I have to write a compare to method inside that object. But if I use this version where the integer is still the same, we still got the exact same stuff. Okay? Object 1 less than object 2, return a negative number, etc. That doesn't change. But the advantage to this type of method is now I can put it in a class by itself. And you call the compare to method on this brand new class. You pass it the objects that you want compared, and I do whatever complex stuff that I need to do to compare them in here. Okay? So compare, so let me try to, it's a difficult concept. It's not easy to understand the difference between these two. Compare to, the way that I've called it and the way it's defined, it only takes one object. I need two objects to compare stuff together. So the other object has to be a calling object. So I have to say object 1 that compare to object 2. That, the consequences of that is now I'm forced to write the compare to object in one of those object classes. Just like we did. Staff member had a compare to method. Okay? If I go to the system where where both objects are passed in as parameters, I'm no longer forced to say object 1 dot compare object 2. Okay? So that frees me up of where I can place this method. And in particular, I can put it in a class by itself. Why might that be important? That opens I'm now opening things up to having all kinds of brand new interesting instance variables. The simplest one being, do I want ascending or descending order? So when I call the constructor for this brand new class that's going to do some comparisons for me, I can tell it I want ascending order, I can tell it I want descending order, and all kinds of other varieties that we'll come up with later. Okay? So we'll be spending a lot of time on those two methods, the pros and cons of both of them, but hopefully I can convince you before we're done with that discussion that compare is the better of the two. It gives you the greater flexibility. All right. See ya.